So, it's the first time doing anything like this, but explain the basics of pointers for my classmates who are struggling with pointers. Dynamic memory allocation. We're on recursion right now, but I think it's important for me to help them understand pointers before I explain dynamic memory allocation or recursion or anything of that sort. So, the first thing I want to cover is what exactly is a pointer. So, a pointer is a variable that stores a memory address. So, if you have your RAM, okay, let me readjust. Segments are memory locations in your RAM. Then each each little segment, and each one is like 1 byte, will have a memory address associated with it. So you have that for all of your memory in your RAM. And a pointer basically just says that my value is stored right here. So pointer just points to that memory address. So if you had a pointer to a character and you had a pointer to a character, then this pointer can hold the address of any other character. So say that I had a character array here, then I can put the address of this using the reference operator, and hold the address. So say that my string was located, oh, that's a weird one. My string was located in that location. Then that address would get stored over there, because this data type is not a character, it's a character pointer, so it holds the address of a pointer rather than holding an actual value. So each value in this character array, each value, see if I can flip the pen over to erase, but that's not happening. Each just clean this up a bit. Again, I'm new to this, so please bear with me. So this array is actually a pointer to where my string 0 starts in memory. So my string 0 is stored here, my string 1 is stored here, all the way to my string 50 to 49 here. And remember, it's always one less. So each of these are just plain characters, but an array is inherently a pointer that points to the start of the array. So it actually points to the head of where my string 0 is found. So, in that sense, arrays are pointers, but pointers aren't arrays, but arrays are pointers because the head of the pointer actually points to the start of an array. So that's why you can treat arrays like pointers in your situations. So what else can you do with pointers? So what's the use of pointers? Why do we use pointers? So say that in my main, right here, and I wanted to manipulate this exact value of my int. So what, and I would do that in a function. So what would I normally do? So of course I would say something like this. Um, I would say, let's reset the value of my int to whatever my function is, pass in my int into this. And now my function is a black box. We don't know what it does, but it doesn't matter. All we know is that my function returns an integer and something is going on in it. And then the last line of that is return structure. Uh, it has variables like int, my, int, and then it does whatever, and then it returns my note. So this is the normal way you would return variables from a function, right? There is a better way to do this. If you defined this as a pointer and you passed the address of my int rather than the value of my int, you could actually manipulate the value of my int in the memory itself. So how would that look like? You could define this as you can define this as a void data type, and you could say this would manipulate whatever. So let's say we're making it, we're doubling it. So my name equals 2. So now we're doubling it, okay? Um, but we don't have to return anything because what we're going to do is we're going to pass the address of this so that we don't have to duplicate it in the new function. Because what happens when you pass it by value, you're duplicating the value into a new um, integer variable, and you're only manipulating the value that's inside that function. So you have to return it because of the scope of the function, the scope of the variable. But when you're passing with an address, you are passing this exact integer into the function. So we can do that by passing the address, and we do that with the reference operator into this. In that sense, um, my int is going to be manipulated directly when you do this, because what ends up happening in the memory is that if this is your memory, and then this takes up these 4 bytes of RAM, like because an int is 4 bytes. So we have that, and that gets put into there. So when you manipulate this, you're manipulating this directly. So you may ask, why is that useful? You are saving 4 bytes of memory. You're saving 4 bytes of memory, and that may not seem like much, but when you start working with structs and arrays of structs, instead of duplicating your struct, instead of duplicating your array, even though arrays are pointers, you can duplicate the array, but you'd be saving a lot of memory when you're passing structs by reference rather than by value. So I keep using these terms, passing by reference and passing by value, right? What does that actually mean? So let's write that out. Reference value. So how you pass by reference is that you are passing the actual value, the pointer to whatever you're trying to manipulate into the function. So if you had just a regular int, pass that into your function as it is. Now my int is not going to get affected by my func at all, no matter what goes on in my func. And that's because of the scope of the duplicated variable in my func. So when you're passing by value, but then this is no, this is a no. Never mind. I thought that's a value. This is I usually do the ref. This is oh, still used to my drawing tablet eraser being functional. That's not. This is reversed. I thought I wrote value at the top. So this is when you're passing by value. There we go. When you're passing by value, you're passing the value of my int. So if my int equaled 5, you're passing 5 into this, and whatever goes on in my func doesn't affect my int. But if you're passing by reference, then you're passing the address of my int into the reference value, the address of my int, the address of wherever this is stored into my func. So then you're passing address of my int into there. So just know that passing by reference is you're passing the address of whatever you're trying to manipulate into the function. And when you pass by value, you're passing the actual value, and the original value is not going to get affected. Whereas if you try to manipulate the value that is in this slot in my func, then you are going to manipulate the original my int because it holds the address of what this value is, and it's gonna manipulate that. So why do we need to pass by reference if we can just return a value not and not have to go around with screwing around with pointers, right? Well, you know how in Python you can return more than one variable from a function? What if you wanted to do that in C? What if you wanted to return more than one value from a function in C? Um, then you would use pointers. So, for instance, you could define 2 pointers, and I'm going to write this in a very specific way, and I will explain it later. So you have one variable, and And then you have, I'm going to define this as a pointer to show you a syntax. So if I wanted to manipulate both of these, let's say I wanted to square this one and cube this one, and or I wanted to find out, like, I wanted to take the sum of these and then multiply both of the numbers by them. That's a better idea. Okay, so let's say that I wanted to take the sum of those and multiply both of the numbers by that. So how would I do that? So I would pass them into my sum, and the first one I could do this. And since this one is already a pointer, we don't have to dereference it because this is already a pointer. We don't have to reference it because it's already a pointer. So we can just write my 2 because we're not trying to get a pointer from this because it's already a pointer. This will get you the pointer of this. This is already a pointer that has that's pointing to a value. You don't have to use a pointer to this. So then you could write your MySum function, 2 pointers here, and then you could say int temp equals p2, then it's p1 plus p2, right? So it's p2, then we can say p1 equals temp 2 times equals temp, and then we don't have to return anything because when you this is a normal scope value. Oh, wait, we need to do this. We need to do that because we're trying to get the values that it's pointing to. So so when you do this, um, you're manipulating the values this is pointing to. So this is the dereference operator. So it's saying take this value, find out what it's pointing to, and then use that value and then put that value here. So that's why we have to use the dereference operator to do these arithmetic operations, because otherwise you're trying to use a pointer and not the actual value that it's pointing to. So this will allow you to use the value that it's pointing to and manipulate it. So now when you go back here, this is going to be so that's 15. 5 times 15 is 75. So this would be changed to 75. 10 times 15 is 150. So this will be 150. So when you actually printf this at the end, you can, this will be, this will print, these will actually have both the values will be manipulated as 75 and 150. So because of that, pointers are very useful for doing arithmetic operations on or whatever operations, function operations on multiple variables and returning multiple variables. That's why it is very useful to have pointers when you're doing multiple multiple things on on 2 variables. So another thing that our class went into is double pointers. And double pointers seem really scary until you realize that it's just a pointer that points to a pointer. and you can chain that all the way up. A triple pointer is a pointer that points to a pointer pointer, and so on. Um, and all that means is that here is your RAM, is your RAM. Here is a pointer, P1, and this is at, let's say, this address, and this has the address of something else. So if you had a pointer to a pointer, all that is that it is pointing to this. It is pointing to this, and it is saying that this is pointing, whatever's at this is pointing to this address. So it just holds a pointer to a pointer. You may ask me, what's the use of that? Why do we need a pointer to a pointer? What's the benefit of having a pointer to a pointer? Now, let's say we had multiple pointers. Say we had 2, 3, and these all pointed to arrays. So this one pointed to an array of 50 items. This one pointed to an array of 40 items. This one pointed to an array of 90 items. And normally, when you want to declare an array, you would say, oh, I have I want a three-dimensional array, and okay, the max thing is 90, so I would say 90, and let's say this are all ints, so int my this, and you would say, oh, but I have so much wasted memory here and wasted memory here. Well, okay, I have 40 extra ints here and 50 extra ints here. This is a waste of memory, right? Like instead, and I can't do anything about that and remove the extra memory. So what you would do is, remember how I said arrays are inherently pointers. So what you can do is you can have a pointer to a pointer, and have that that pointer, the double pointer, point to this, and then hold these in an array instead of holding each one of these in an array. So each one of these are the same size. Each one of these pointers are the same size, but they each point to a differently sized array. So you would be able to have a multidimensional array with differently sized pointers because they have different size values. So it makes it a lot easier to keep track of arrays with different sizes. So how would you do something like that? So it's actually pretty. Um, this involves a little bit of dynamic memory allocation, which I will go over in another video. But for now, I'm just going to cover pointers. But just bear with me for now. So let's say I had an integer array of double pointers, and I wanted to have three of them. So I would first typecast this from that malloc because malloc returns a void, and I want to make sure that an int goes into an int. An int double pointer is going into an int double pointer. That's important. And so I want 3 of these pointers, and since I'm doing pointers, int pointers, then I have to take the size of int pointers, single pointers. So all this is saying is that let's turn this, whatever number of bytes this returns, into int pointer bytes, and I want 3 of these of int pointers, and these are how many bytes that this takes up. So that's all this is saying. So now I have space for 3 int pointers. So say that I had my int 1, and remember, arrays are pointers, and this is, what did I say, this is 50, and so now this has 50 bytes for it, and then I have an array 2, and this was 40 bytes, and an array 3, this was 90 bytes. And now what I could do is that because arrays are pointers and I don't have to dereference them or anything, I could just say this equals array 1, because this plain array 1 is inherently of the type int pointer. So because of that, you can just put that in there. The same thing with the rest. So we can put the pointers of each of these arrays into into these pointers. So now this just holds a pointer to this array, and a pointer to that array, and a pointer to this array, and now you can iterate this like a normal array, and you can get values from that. You just need to bear in mind your bounds and what you set for you allocated for each value. So, for instance, if you malloc these instead of just defining them like that, you had to keep track of that. But yeah, that's the basics of double pointers, and these become very useful when you have arrays of structs, because structs are really large pieces of memory. You typically define them as pointers to structs rather than rather than um, rather than plain structs, an array of structs, because that would take up a huge amount of memory in one chunk of memory, and that's very inefficient. So by having pointers to structs and putting those arrays in pointer pointers, you can dynamically allocate that size of that array and have a pointer to the next struct, a pointer to the next struct, and have a linked list of structs as you build your list of structs. And that becomes very useful when you're building binary trees and linked lists and all that fun stuff. But yeah, this was the basics of pointers, and I just want to make one more last thing clear. So say that we have our variable, and then we have a pointer to a variable, and then a pointer to a variable, and then we had our address here, which held the value of 5. So when you are using this operator, you are getting that. That's pointer. When you're using this on here, you're getting the pointer there. When you're using this here, you're getting the the pointer of that. So you were just removing a star every time you take a pointer. So when you do this, you are you are saying get me the value that's stored there. When you're doing this, you're saying get me the value that's stored there. When you're doing this, you're it should really be like, so this will get you that value. Putting this there will get you that value. Putting this there will get you that value. Um, will return, will see, tell you what's in what like will return that value. I'm not saying it properly. I'm not able to explain this properly, but like you'd be able to just remember that this thing, the dereferencer operator gets you the value. So this gets you value stored pointer, and this gets you address of variable. So that's the most important thing to remember when you are using these operators on dairies. And remember, you don't have to use this on an array to get to pass the values. Uh, when you're passing the address, when you're passing the address in an array, you don't have to do this because they are already pointers. You don't have to get the pointer to the array because they are already pointers. So when you're passing arrays, you don't have to reference them to get the address. But yeah, that is basically all I have to share to the pointers. I hope this was helpful. I'm going to be making one on dynamic memory allocation later. Um, yeah, if you have any feedback or need to improve on anything, let me know. I will work on that. Uh, thank you. Have a good night.